Good evening, everyone. I hope everyone is fine. In the last class, we were doing sets, and we have done till the operations on sets, right? I think we have done till complements of sets in the last class. And today we are going to start with the applications, right? So I'll just share the screen with you. I hope the screen is visible to everyone. In the last class, we have done De Morgan's law, uh, which actually turns union into intersection and intersection into union when we apply the complement of the sets, right? So these were the laws that we had. So let us try example for this one, and then we will move to the next topic, right? Just a second. De Morgan's law, these are the De Morgan's laws, and you will have to remember these De Morgan's law because these are very important, right? Um, so let us first discuss I think we haven't discussed the Venn diagram of De Morgan's law, right? Okay, so I'll just form the Venn diagram also for these two, and then we will move to the so we have the first De Morgan's law is A union B whole complement is equal to A complement intersection B complement, right? So basically, complement means you have to find the difference of the set uh, with respect to the universal set, right? For example, we have done the complement of set. So A complement is U minus A. So basically, if it is A union B whole complement is there, which means you have to find the difference of U minus A union B whole, right? So if I draw the figure for this one, a Venn diagram, let us say this is A set and this is B set, right? The whole set A union B will be the region inside A and B, right? So the complement of A union B will be the region outside A and B. This whole region of the rectangle except A and B. So this will be the required area, or you can say required portion of this. And this is U here, right? So this denotes A union B whole complement. And this is also equal to A complement intersection B complement. right? And how can we say that these are equal? So we can prove it by using these Venn diagrams also. See, if I draw the Venn diagram for this RHS part of the first one, you will get A here, and you will get, so this is A and this is B set. So if we talk about A complement first, if we shade the A complement part, it will be all the region of this rectangle except A. So this will be the region that comes under A complement, right? Then in this same figure, we are going to draw the, or we are going to shade the B complement region also. So it is uh, B means all the region of U except this set B. So I hope this is clear to you. So this is the region uh, we have done for A complement as well as for B complement. Now we have to find the intersection of these two. Intersection means whatever is common in between these two will be the shaded region, right? Will actually be equal to A complement intersection B complement. So इसमें आपको दिख रहा होगा some of the part are double shaded, some of the parts are single shaded, and some of the part is only means there is no shading there, right? So intersection means which is common, and common part is the one where we have double shading. So double shading you can see here in this region, all the region except A and B. If this is A, this is B, so the double shading is in this region only, right? So this will become your, so now you can see these both are equal to each other, right? I hope it is clear to the Venn diagram how these De Morgan's law are working according to the Venn diagram, right? So you will see it for the second one also. Second figure also will be the same, right? So I'll just make the figure of the second one because both the figures will be the same. So I'll just draw it once only. Suppose this is A, this is B, and we have to uh, shade the part which is A intersection B whole complement. Means the part of this whole figure except A intersection B. So A intersection B is this middle one, right? So except this part, you have to shade all the region of this. So like this, all the region of this box will be shaded like this. So except this middle portion here, because this is A intersection B, except this one, we have shaded all the region here. And it denotes A intersection B whole complement, and also it is equal to A complement union B complement, right? I hope it is clear. Okay. So now let us come to one question where we are going to verify these De Morgan's law. So let us take an example here. So question is, suppose you have a universal set which has 1, 2, 3, 4, and up to 10 elements here, right? So if this has if this has 10 elements here, and A is another set which is having, let us say, 1, 3, 5, 7. These are the elements, and B is another set which is having 2, 3, 5, 7, and yeah, that's it, right? So these are the elements. So first of all, we are going to verify De Morgan's law. For that, we need A complement and B complement. So if we want to find A complement here, it is U minus A, which means all the elements of U except the elements of A. So it will be 2 here, it will be 4, 6, 8, 9, and 10. These are the elements in A complement, and similarly B complement are the elements of U except B. So it will become 1, uh, 4, 6, 8, 9, and 10. Right? So these are the elements in B complement. Now let us prove the first one. So A union B whole complement is equal to A complement intersection B complement. This is the first De Morgan's law. So let us take LHS here. LHS is A union B whole complement. First of all, find out A union B. So A union B will be 1, 2, 3, 5, 7, right? And the complement of this set, we want to find out the complement of this set. So complement is basically U minus this whole set. 1, 2, 3, 5, 7, right? So U minus 1, 2, 3, 5, 7 will be equal to all the elements of U except these 5 elements. So you will get 4, 6, 8, 9, and 10. These are the elements. Now let us come to the RHS part, which is A complement intersection B complement. So A complement is this one and B complement is this one. We have to find the intersection of these sets. Intersection means the common part of these two sets. So these will also be 4, 6, 8, 9, and 10, right? So you can see that both of them are equal. So LHS is equal to RHS. So the first is verified. First, De Morgan's law is verified, right? Now let us come to the, so this was the first one. Now come to the second one, which is A intersection B whole complement is equal to A complement union B complement. So let us take LHS here, which is A intersection B whole complement. So now A intersection B. First of all, find A intersection B. A intersection B is 3, 5, and 7. And we have to find its complement, which is U minus 3, 5, 7. Right? So all the elements of U except 3, 5, and 7 we have to write here. So this will become 1, 2, 4, 6, 8, 9, and 10. These are the elements. Now let us take the RHS here. A complement union B complement. So union represents, we have A complement and we have B complement. Union represents the, uh, basically we have to write all the elements of A intersection and B, sorry, A complement and B complement in it. So 1, 2, then we have 4, 6, 8, 9, and 10. So you can see that all the elements of these are matching. So LHS is equal to RHS again. And hence we have proved the second De Morgan's law also by using these sets. I hope it is clear. Okay, so let's come to the next one. After this one, let me check if we have done the. Okay, so now let us come to the next one, uh, which is exercise number 1.3. And exercise 1.3 may. I think we have done a few questions, but we are now left with applications of sets, right? So we have to first complete that part of the exercise and then we will move to the application part. So I'll just share the screen with you for this one. I hope the screen is visible to everyone. Okay, so we have example number 19th here. We have done it right now, right? So just a second. So in the exercise, I think we have discussed a few questions in the last class about union and intersection and the complement of sets. I think I have told you about. Have I told you about disjoint sets also? Okay. So disjoint sets are the one which do not have anything in common, right? Jinka intersection is 5. So that uh, those sets are known as disjoint sets जिनका intersection 5 हो जाता है. I think we have discussed A minus B, all these things also. So let us do the fifth question. Question number fifth may we have the Venn diagram. Use the Venn diagram given below to answer the questions that follow. Right. So you have A, B, C, three sets here. The box represents the universal set, right? And we have to find A complement, B complement, and we have other things also. Let us check here. Yeah. So these are the things that we want to find out. So here, first of all, let us talk about A complement. If we talk about U here, so it will contain all the elements here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and I think 12 and 13. I think 12 is not there, 13 is there. So we have 1, 2, 3, 4, 5, 6, 7, then 8 we have, 9, 10, 11. 12 is not there and 13 is there, right? So these are the elements of U. So you can write it here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 13. These are the elements of U, right? Universal set. Now let us talk about A complement. A complement is U minus A. So if we talk about A only, A set contains 1, 4, 5, 8, and 11. These are the elements which are in A. You can see here also in the diagram 1, 4, 5, 8, and 11. These are the elements in A. So U minus A will be all the elements of U except the elements of A. So you'll write down 2, 3, 6, 7, 9, 10, and 13. These are the elements of A complement. Similarly, B complement will be U minus B. But for that we want B. So write down the set B here. It contains 2, 3, 4, and 5. These are the elements that are contained in B. So B complement will become 1, 6, 7, 8, 9, 10, 11, and 13. 13, right? So these are the elements in B complement. Then we have A intersection B whole complement. For that we want A intersection B first. A intersection B, you can see 4 is common and 5 is common. So 4 and 5 are there in A intersection B. And its complement will be all the elements of U except 4 and 5. So it will become 1, 2, 3, 4, 5, we don't have to include, and then 6, 7, 8, 9, 10, 11, and 13. These are the elements of A intersection B whole complement. Similarly, A complement union B complement. So you can see A complement और B complement हम already निकाल चुके हैं. तो उनका हमें बस union करना है. So union will be 1, 2, 3, 6, 7, 8, 9, 10, 11, and 13. Right? So this is how De Morgan's law is also verified. A intersection B whole complement is equal to A complement union B complement. Right? Then let us come to the fifth part, which is A intersection B intersection C. Means the common part of all the three. So that you can check from the Venn diagram here. The part which is common among all these three sets is this one, the middle one, right? This comes in all of these. So it will be 5 here. Then we have A intersection B union C. But for that, we want B union C first. So we will have to write B union C here. B union C means all the elements coming in B and C both. So 2, 3, 4, 5, 6, 8, 9. These are the elements that are coming in B and C combined. So if we want the intersection of if we want the intersection of A with B union C. So A is here, this one and this one. We want the intersection of these two. So you have to check the common part of these. 4 is the common one, 5 is the common one, and 8. So 4, 5, and 8. These are the three elements which are in A intersection B union C. I hope this is clear to everyone. Okay, now let us come to the next one. I will just erase this one. Uh, so in the next question number 6, we have to verify that A minus B is equal to A intersection B complement. But well, actually, that's a formula that we have to remember also, and we have to verify it here that they are equal. But actually, you will have to learn it also for the application part, right? So A minus B is equal to A intersection B complement होता है. So that we have to first uh, prove here. So here you can see, first of all, write down A, the set A from this one. So it contains these elements 1, 5, 6, 8, and 13. These are the elements in A. Then B is 2, 3, 5, 7, 13. These are the elements in B. So if we talk about A minus B here, this is the LHS part. If we talk about A minus B here, you will get all the elements of A except the common elements of B, right? So common elements are 5 and 13, right? So write down all the elements of A except these common elements. So it is 1, 6, 8. These are the elements in A minus B. Now let us come to the RHS part where we have to write A intersection B complement. So A is already given, but we have to find B complement first. So I'll just write it here. B complement is all the elements of U except B. So we don't have to write 2, 3, 5, 7, 13. Except that we have to write everything. So it will be 1, 4, 6, 8, and 9. I guess these are the elements of U which are not there in B. So now we have to do the intersection of A and B complement. So A is this one. We have to find all the common parts, common elements. So 6 is there. 6 is the common part. 8 is the common part. And 1 is also the common one. So yeah, 1, 6, and 8. And you can see that LHS is equal to RHS now. So we have proved that these two relations are equal. A minus B is equal to A intersection B complement, right? So this is how we can prove these uh, formulas. I hope it's clear to everyone. Okay. So now let us come to the next. The next one is the application part. There are only 7 minutes left. So I'll just end this meeting. Then you can rejoin it again. It will be a 40-minute session, right? Otherwise, this recording will be stopped in between. So I'll just end this meeting here. Please join it again with the same link.